Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Dutch Dormers by Dubious Mobius. And here are the rules. It's irregular Squishdoku, where we need to place the digits 1 through 9 once each in every 9-cell region without repeats in any row or column. So, cells on region borders, that is the dashed lines, are shared between multiple regions. So this is the main reason why I wanted to do this, because I've never seen an irregular Squishdoku, so I wanted to try it out and see what it's like. I've done Squishdokus before. I haven't been the biggest fan, but it's okay. But I'm very curious how the irregular version is going to do. We also have Dutch flatmates, where every 5 in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. So, for example, if there were a 5 here, there would have to be either a 1 above it or a 9 below it. That's all that's required. It could have both, but it doesn't need both. And that's how Dutch flatmates work. We also have Kropke dots, where white dots separate cells with consecutive digits, and black dots separate cells with digits in a 1-to-2 ratio, and not all dots are given. So, for example, if this were, say, a 6, this would have to be 5 or 7 to be consecutive with it, because there's a white dot between them. If this were, say, a 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio that's between those two digits, because there's a black dot between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this is interesting. Let's first mark all the black dots. So 5, 7, and 9 can never be next to a black dot in normal Sudoku, or even irregular Squishdoku, because the only digits which 5, 7, and 9, if you have them, you get 2.5, 3.5, and 4.5. And if you double them, you get 10, 14, or 18, none of which are digits. So these have to be 1, 2, 3, 4, 6, and 8. Well, in this middle combination box, we have a 1, 2, 3, 4, 6, 8 sextuplet, right? These are all part of the middle box. So that means the remaining digits in that middle, or region, I should say, not box. It's not a box. The middle digits in that region then must be 5, 7, and 9 remaining, because those are the only digits which can be part of, those are the only digits left that can be part of these digits. And therefore, 5, 7, and 9 are consecutive only with 4, 6, and 8. So this is 4, 6, 8. That's 4, 6, 8. 4, 6, and 8. 4 can only be in a 1-to-2 ratio. In this box, 1 has to be in a 1, or it's region, I should say. I keep saying box. I don't know why. In this region, 1 and 2, 1 has to be in a 1-to-2 ratio with 2. Because 1 cannot be on either of these ends, which are in a 1-to-2 ratio with these digits here. Right? 4 can only be, if this is 4, this can only be 2 or 8 with it. If it's 6, that has to be 3. Same here. If this is 4, this is 2 or 8 in a 1-to-2 ratio. And if this is 6, this is 3. Well, we know in this region there must be a 1, and it has to be in a 1-to-2 ratio with another digit, which would be 2. Therefore, that eliminates 2 from all possibilities. of being... Oh, this could also be 4, right? So you have 3, 4, or 8 here. 3, 4, or 8. So you have in the central box a 1 having to be in a 1 to 2 ratio with 2. You also have 6, which has to be in a 1 to 2 ratio with 3. So this must be a 1, 2, 3, 6 quadruplet in the central region, which eliminates 3 and 6 from the remaining central region. Well, this is 4, 8 as a pair. This is 4, 8 as a pair. That eliminates 4 and 8 in the rest of the row. Remaining digits in column 4 then are 1, 2, 3, and 6. Okay. These digits are consecutive and cannot have 4 or 8 in them. I guess, yeah, what are the remaining digits of column... What are the remaining digits of row 6? Well, there's a lot of them. We know in these regions, in the top trapezoidal region and the bottom trapezoidal region, you cannot have 4 and 8. Does that tell us anything? I don't know. Let's do remaining digits in row 6. We have 1, 2, 3, 5, 6, 9, 7, 9. 1, 2, 3, 5, 6, 7, 9. Oh. That's interesting. We have in this bottom left region, I guess region 7. We can still number them 1, 2, 3, 4, 4, 5, 6, 7, 8, and 9. In region 7, we have 3 cells guaranteed to be from 1, 2, 3, or 6. I guess this could be 3, 6. So I think we're guaranteed that this has to be a 4. This cannot be 3 and 6 or 1 and 2, because if that were the case, the problem is that those 4 cells would eliminate all possibilities for that cell there. So this cannot be 3. If this is 3, 6, this becomes 1, 2, and then this doesn't have a possibility. If this is 1, 2, this becomes 3, 6, and then this doesn't have a possibility. So it cannot have 1, 3, or 6 here. We are guaranteed a 4 here, though. It could be 2 with 4 here, this being 3, 6, and this being 1. We don't know. So that means the remaining digits in this region you cannot have 4. You must have 5, 7, and 9 as possibilities. And you could have the other 1, 2, 3, 6, right? Or 8. This can't be 8. But we know 4 is guaranteed here. Okay. These are different digits. Okay, so let's mark those. So this is A. This is A, and we'll mark that as B, which makes that B. This is A. So A is in... What digits are A in? A is in region 2, region 6, 5, 8, and 9. So A is in all of these, cannot be basically any of these cells. Anything that shares a cell with A. So cannot be these, cannot be here, cannot be here, cannot be here, 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 here. Can't be here, can't be here. So A has to be one of these two digits. Well, where is, so, okay. Again, A cannot be any of these. Can't be part of the green. Can't be in row 2. Can't be part of the region 6. No region 5. No region 8. No region 9. Cannot be here. Therefore, in region 3, it has to be one of those two. Can't be here. Can't be here then. It has to be part of rows. It has to be part of region 7. Region 1 and region 4. It cannot be part of all 3 regions at the same time. But we don't know where specifically it has to be. How about B? B also has that issue. B cannot be part of region 2 anymore. No region 1. No region 4. Can't be in row 2. Can't be in column 3. Can't be in region 6 or 5. Sorry, region 8 or 5. Can't be in row 6. So B has to be one of these two cells. Interesting. Which could be 4 or it could be 8. B. So again, where is B? B cannot be in region 2, region 1, region 4, or region 5. It's part of region 7 in one of these two cells, so that eliminates those. Can't be part of region 8, can't be row 9, can't be here. Can't be here. Can't be in row 2. If it were trying to be part of region, oh, it could be here. I was gonna say that it kind of forces it to be there, but it's actually not. It could actually be here. B cannot be either of these because that would be consecutive with A, and we know 4 and 8 are not consecutive. So, B could be here or one of these two. Let's mark these as C and D, and then E and F here. We know one of this is a 1-2 pair, the other is 3-6. Where can C and D be? D cannot be part of any of these cells. Can't be part of 4, 5, or 8. as a region. Can't be in column 3, can't be in column 5. So, where could it be? Oh, every 5 has to have a 1 above it or a 9 directly below it. Well, none of these 5s are having a 1 above it at all, so it must have a 9 directly below it. So this cannot be 9 here. This can't be 5. It doesn't have a 9 directly below it. So 5 is one of these two, which means 9 is one of these two. If 5 is here, okay, 7 and 9 are not consecutive with 4. So therefore this must be 8. So B is 8, A is 4. That means B 8 there and this 4 there. 8 cannot be here. 8 cannot be on this in region 1 or 4. That eliminates 8 from being here, so this must be a 2-8 pair. Sorry, 4-8 pair, because there's no other place for 8. So that means 4 has to be here. Because 4 cannot be in region 9, region 6, or region 2. So that eliminates all of these, and 4 can't be in this column or this row. So this is 4 with 3 or 5 here. This is 4, 8 as a pair. Okay. So 8 has to be one of these 3. We're not sure which. For region 3. One of these has to have a 5. Well, 4 is only consecutive with 5, not 7. So this is 5, which has to have a 9 below it, which makes that a 7. That eliminates 7 from the rest of row 5 and region 8. So where is the 7 in region 7? It has to be here. So that's 7. That means we have a 5-9 pair here, interestingly enough. So 5 and 9 both have to be here, which means this cannot be 5 or 9. It could be 1, 2, 3, 4, 6. No 5, 7, 9 here. 9 cannot be here. Okay, 4 cannot be in region 8, so this can't be 4. So this is 1, 2, 3, or 6, and it cannot be C, D, or F, so this has to be E. E sees E and F see all the digits in, well, no, E sees all these digits here. Yeah, so E sees these digits by being in the same row and column and region as these. So E in region 7 must be here, which means this is an EF pair. This cannot then be... This is EF as a pair, which means this can't be C, D, E, or F. So it's no 1, 2, 3, 6. This is 5 or 9. Therefore, this cell sees both C, D, E, and F. So this can't be 1, 2, 3, or 6. So this is 5, 9. And this has to be 1, 2, 3, or 6 here. So this is C or D here. And this is C or D. E is here, F is here, which means we need a 5, 9, and a 1, 2, 3, 6 here. Okay. We are missing a 4 in region. So what are we missing? We're missing F in region 4, a 5, 9, a 7, and a 4. No, we're not missing 5, 9. Both 5, 9s are here. So we're missing F, 7, and 4. So this is 4, 7, and F guaranteed to be there. Ow. Where is F in region? So D, we're missing D, E. So D is here in region 8, which means this cannot be D. This must be C, which means this can't be C. That must be D. So this is D, that's D. I guess we could color them, maybe? I don't know. The coloring would sort of interfere with the regions, but maybe that would be okay. Let's try it. Let's try to color. Red, green. We'll make that pink. Actually, we have... Let's make this red and that green. And this orange and this blue. So that makes this orange. This is orange-blue as a pair. These two eliminate all possibilities for that. And it can't be E or F. So this must be C, which makes that a D. F is one of these three. So that means we have an F guaranteed here, an F guaranteed here. If F is this one, that would force F to be here. F could not be any of these digits then, which would mean region 1 wouldn't have an F. So F has to be one of those two. This can't be F. We have an F guaranteed here and an F guaranteed here. This is 4, 8 as a pair. Where is F in region 2? Has to be one of these two. So F is one of those two. Where is F in region 9? Can't be here, can't be here. Where's F in region 8? This is not F. This can't be, this can't be. This is C. Can't be any of these. This has to be F here. So this is not 5 or 9. Therefore, this is F here. Let's remove the letterings. This is 1, 2, 3, 6 quadruplet as a quadruplet, which eliminates 1, 2, 3, 6 in the rest of the region. This will make, well, let's make this yellow and this pink. That forces this to be yellow there. Okay. Green cannot be any of these. Can't be here. So green in region 2 must be here or here. So this has to be, it could be blue, red, or orange there. We have red here, red here. So red is in region 1, region 4, 5, 8, and 7. So we need a red in region. Red can't be here in region 2. Could be any of these. Where is red in region 6? Can't be here. Can't be here. It's one of these three. Interesting. Four, 7, and F. F is one of these two. We have a guaranteed 4 also. So we have a guaranteed 4 here and a guaranteed 4 here, which means the rest of the columns cannot contain a 4. So if 4 were here, there would be no 4 in region 1 here, and there couldn't be a 4 in the rest of the columns because column 1 and 2 already has a 4 guaranteed. Therefore, this can't be 4. This is 7, which means this can't be 7. This is a 4F pair here. So this is blue and 4. Remaining digits in... So we have a 7 here, a 7 here. We need a 7 in the region 1. Also, 7 can't be here in region 2, can't be here, can't be here. So 7 has to be one of these 2 digits in region 2. That means we're guaranteed a 7 in region 6, because that's one of those. Let's just look at remaining digits in region 2. So we have 1, 2, 3, 6, 7, 9, right? So 7 can't be here or here. 5 has to have a 1 above it or a 9 below it. This 5 does not have a 1 above it, does not have a 9 below it. So yellow has to be 9, which makes pink 5. And 5 has to have a 1 above it. So all the oranges are 1. So these are 1, which makes the blues 2. So this is a 4-2 pair. So all the blue, this is 1 and 2 as a pair. That eliminates 1, and so we can remove that coloring. Let's remove this coloring. We know these are 2. Cannot be 1 and 2 then, so this is 3 and 6 as a pair. This 9 eliminates 9 here. This can't be 1. This can't be 1 or 2 here. Two is here. So if this were 1, well, it can't have... Okay, 9 cannot be either of these. So since 9 cannot be either of these, if there were a 5 here, which would be 4 and 5, the 5 would have to have a 9 below it, but 9 can't be here because of the 8 in the row. So this has to be a 3-4 pair, which eliminates 3 and 4 in the rest of the box and row. So where is 3 in region 2? It has to be here. So that's 3, which makes the greens 6s and the reds 3s. Okay. 6 eliminates 6 as a possibility there. 9 cannot be either of these. This can't be... So we need a 7 in... This 1 eliminates 1 in the rest of region 2. We have a 2-6 pair remaining in region 2, which eliminates 2 and 6 in the rest of the region. So this is 9. That means this can't be 6 and 7, which makes this... Wait, that's problematic. 6 eliminates 6 here. That's... Yeah, I don't know about those numbers. We do know 3 and 4. Okay, so this has to be 5, 6, 7, 8. These, let's just clear these. This has to be 1, 2, or 3. Cannot be 3 because of the 3, 4 pair in the row. 1 eliminates 1 here, so that's 2. Remaining digits here cannot be 2, cannot be 4. It has to be 9. And that, so 5 and 8 eliminate 5 and 8 in the rest of the region. So this is 6, 7, 6, 7. 7 eliminates 7 here. So this is 6, which makes this 7. So there's no 7 or 6 here. It's 5 or 8. If this were 5, it does not have a 1 above it or a 9 below it. So this must be 8, which means this cannot be 8 here. Okay. These are consecutive. No 7, so it could be no 7 or 8, so it's 5, 6. It cannot have 3 or 4, so it would be 1 or 2, if that were the case. So it's either 5, 6, or 1, 2. Cannot be 1, 2 because of the 2 in the region, so this must be 5, 6, which means we have 1 and 9 below it to fill the region 3 out. Remaining digits of column of row 1 can be 1, 5, or 7. That's still fine. Remaining digits of row 2 could be 1, 2, 3, or 9. And it cannot be 2 because of the 2, 4 pair in the region. Remaining digits of row... We need a 5 in this region, and 5 can't be here either. So therefore, 5 has to be here. It has to have a 9 below it. So this can't be 9. Whereas 3 in region 1, it has to be here. So this is 3. But we have a problem because this is 1 and this is 1. How did we mess this up? Let me go back. Again, these cells are in a 1 to 2 ratio. So that's 1, 2, 3, 4, 6, and 8. In region 5, we have a 1, 2, 3, 4, 6, 8 quintuplet, or sextuplet, which means these have to be 5, 7, 9. To be consecutive with that is 4, 6, and 8. 4 being here means this has to be 2 or 8. 6 being here means this would be 3. 8 would mean that's a 4. So this is 2, 3, 4, 8. In region 5, then, we have a 1, which can only be with 2 in a 1 to 2 ratio, and a 6, which can only be with 3 in a 1 to 2 ratio. So this has to be 1, 2, 3, 6, which eliminates 1, 2, 3, 6 in the rest of the region. So this becomes a 4, 8 pair, which would then be in a ratio, 1 to 2 ratio with only 4, 8. 5 has to be above a 9 or below a 1. And these can't be above, these can't have a 1 above it. So it must have a 9 below it, which means this can't be 9. 5 can't be here either. 7 and 9 is only consecutive with 8. So this is 8, that's 4, which makes that 4 and 8. 4 is not consecutive with 7, so this is 5, which forces a 9 to be below it, which makes that 7. This cannot be 4 and 8 again. Remaining digits. So this again is red, green, blue, and orange. Remaining digits in column 5 are 1, 2, 3, 6. How did we get that was 1, 2, 3, and 6 there? We do know, again, this cannot be 1, 2, 3, or 6 because it cannot be the pair 1, 2, or 3 or 6 because if that's the case, in region 7, we would have 5 cells which require those digits. So this can't be 1, this can't be 3 or 6. This is guaranteed to have a 4. 7 cannot be any of these cells because it sees that cell because 7's in the row, and it sees that cell because they're in the same region. So 7 has to be here. Why was this 5 or 9? Green and red. How did we get that this was not 5 or 9? Blue and orange cannot be here. Red and green cannot be here. Where is 4? So 4 cannot be here, here, here. It cannot be in the green region. Oh, 4 could be there. Okay, so that might have been kind of an error there. So that might have been one of the errors. Remaining digits of region 8. We have 1, 2, 3, 5, 6, and 9, right? 8 is already part of region 1. So this can't be 8. We need an 8 in region. We don't need a. We already have an 8 in region 1, 2, 4, and 5. That eliminates 8 from being here. Where is 8 in region 7 then? It has to be here. Because it can't be any of these. Because 8 is here. So this 8 eliminates possibilities for 8 from being these cells. Which means in region 7 it must be here. So this is a 4-8 pair. Okay. So I think the error was here, actually. I think 4 could be here. No, 4 cannot be here. Right. This 4 eliminates 4 from region 9. And region 8. And region 6. And region 5. So none of these can be 4. This can't be 4 because of 4 in the row. These can't be 4, so no, this must be 4. So this is 4 with 3 or 5. So that's still the same. How did we know this was not 5? Oh, because we need a 5, 9 in this cell and these two cells. So this cannot be 5 or 9. Therefore, this is not blue, 1, 2, 3, 6. It can't be red or green, so this must be orange. Orange 1, 2, 3, 6 means this can't be orange 1, 2, 3, 6. This can't be orange 1, 2, 3, 6. Orange 1, 2, 3, 6 has to be this combination. So this sees all of orange and blue because 1 and 2 can only be in a 1 to 2 ratio with each other, and 3 and 6 can only be in a 1 to 2 ratio with each other out of 1, 2, 3, and 6. So this cannot be 1, 2, 3, 6. It's 5 or 9. This sees all 4 cells, these 3 by the same region, this cell by in the same row. So this cannot be 1, 2, 3, 6. It's 5 or 9, which forces this to be 1, 2, 3, 6. So red in region 7, this must be a red-green pair. This red eliminates red here, so this is green, which makes this red. Okay. I guess this could have a 5 and that's a 1. No, this is, again, we're missing. Oh, F. Oh, yeah. So blue is one of these 3 digits. 4 is one of these 3 digits. And 7 is one of these 3 digits. Well, we have a guaranteed blue here. We have a guaranteed blue here. If we have blue here and blue here, None of these can be blue. Oh, yeah. If we have a blue here and that forces a blue to be here. That means none of these can be blue. Where is the blue in region 1 then? It can't be. So blue can't be here. So blue's one of these two. Similarly, if we have a 4 here, we have a guaranteed 4 here. If we have a 4 here, that forces a 4 to be here. 4 cannot be any of these cells then. Where's the 4 in region 1? You don't have one. So this can't be 4 either. So this must be 4 or blue. This is guaranteed to be 7. Therefore, this digit does not have a 1 above it or a 9 below it, so it cannot be 5. It's 9, which forces that to be 5. That eliminates 5 in the rest of the region. So this is 9. 5 has to have a 9 below it or a 1 above it. It cannot have a 9 below it, so it must have a 1 above it, which means orange is 1. And blue is 2. So orange is 1. This becomes a 1-2 pair, which eliminates 1 and 2 in the rest of the region. This is 2, 4 as a pair. We don't need coloring, you know, for orange or blue. Okay. Remaining digits. So 4 does have to be here. Again, you cannot have 5 here. That would force a 9 to be below it, but 9's only consecutive with 8. Therefore, this is 3 and 4. No 1 or 2 here. This 1, 2. So where's 2 in? Yeah, we have a 3, 6 pair in region 8. So this can't be 3 or 6. It's 9. This remaining digit has to be, cannot be 3 or 6. 1, 2, 4, 5, 7, 8, 9. So this is 2. Okay. Remaining digits in region 2. We have to have, okay, let's just do column 5. 3, 5, 6, 7, 8. No 8 in region 2 because of 8 there. No 5 in region 2 because of 5 there. 1 eliminates 1 as a possibility there. This can't be 3 because of the 3, 4 pair in the row. This can't be 3 because of the 3, 4 pair in the row. This can't be 3 because of the 3, 4 pair in the region. Where is 3? Cannot be here. It must be here in region 2. So therefore, green is 6. Red is 3. Remaining digits of column 3 are 2, 4, and 9. No 4 because of 4 in the region. Digits in... So where is 7 in region 2? Can't be here. Can't be any of these. So 7 has to be here, which means this can't be 7 here. Where is 9 in region 2? Cannot be. It has to be here. Because it can't be here or here. So this is a 2, 6 pair, which eliminates 2 and 6 in the rest of the row. But we have a 2, 4 pair here, which means this can't be 2. It's 6, which makes that 2. Okay. Remaining digits in... row 1. We have 1, 5, 1, 5, 7, 8. No 8 here. Again, so remaining digits in region 3. We have 1, 5, 6, 8, 9. 8 can't be here. 1 is not consecutive with that. It's 5 and 6 as a pair, which eliminates 5 here, so that's 8. No 5, 6, or 8 here. So this is 1, 9 as a pair. Remaining digits of... Oh, we have a 3 here. That's why. That's where I messed up. There's a 3 here in the region 1. So remaining digits of region 1 are 1, 5, 7, 9. No 5 or 7 here. This is 1, 9 as a pair, which eliminates 1 and 9 in the rest of the region. This, if it were 5, it does have a 1 above it. Okay, so 5 could be either of these. 9 eliminates 9 here, so that's 1, which makes that 9. 5 no longer has a 1 above it here, so this can't be 5. That's 7, which makes that 5. 1 eliminates 1 here, so it's 2 and 1. 2 eliminates 2 here, so it's 4 and 2. 4 eliminates 4 here, so it's 8 and 4. 1 eliminates 1 here, so it's 9 and 1. 5 must have a 9 below it, so this is 5. That's 6. Yeah, so I messed up. I forgot that this was a 3 in part of region 1. Okay. Remaining digits of region 6 are 5, 6, and 8. 5 has to be here, cannot be here. 6 and 8 as a pair is here. Okay, remaining digits of row 7 could be 1, 3, or 5, and this can't be 1 or 5, so this is 3. Remaining digits of row 6, that's 3 in the corner. We celebrate because we're getting close to solving this. It's 3, which can't be here. 6, 7, or 9. Well, this can't be 6, 8, or 9 because of a 6, 8, 9 triplet in the column. This 3 eliminates 3 here, so it's 4 and 3. Okay. So no 6 or 9 here, so this is 7. We have, where is 9 in region 7? Or region 9 can't be here because of 9 in the row, so 9 has to be there. That means this is a 6, 8 pair. No, we have 1, 2, 3, 4, 5. Yeah, 6, 8 as a pair. 6 can't be here because of 6 in the column, so that's 8, which makes that 6, which makes that 8. Yeah, definitely not used to the irregular regions to squish Doku. Definitely missed a couple of things. Very interesting how it interacts, though. But I'm just not used to finding where things are, right? So it's kind of hard to spot this for region 1. So I think I set a 3 there because of that. Because I didn't realize that this was part of the same region. I don't know. Just maybe more. We need to practice these more to get a better intuition for these irregular region squish Doku. It does have a lot of potential. There's a lot of interesting things you can do. You have a lot of interesting things already with irregular Sudoku, and then adding that to squish Doku makes things even more interesting, I guess. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.